Hello everyone, my name is Yadapuri. I am currently in my final year of BTech in Computer Science and Engineering from Kaziranga University, Jorhat, Assam. Today I will be presenting what I have learned during my internship at Emerge along with a demonstration of a project that I have developed during this period. Let's move on the content of my today's presentation. It includes topic I had learned during my internship period, introduction to microwave oven requirements, microcontroller and microprocessor, PICSIMLab, CLCD, matrix keypad, ISR, timer, and project implementation. Let's move to next slide. In this, we will see the topic I had learned during my internship period. During my internship, I acquired a solid foundation in the basics of the C programming language. This includes understanding conditional statement, mastering various types of loops, exploring arrays, pointer, and storage classes. In addition to the basics of C programming, I also gained substantial knowledge in the field of embedded system and microcontroller. I learned to use MPLAB, XC8 compiler, and the PICSIMLab simulator. I became familiar with various peripherals of the PIC16F877A microcontroller and learned to interface with them. Further, I attempted multiple quizzes that helped reinforce my understanding of this concept. I also had the opportunity to attend the DISA workshop, which contributes significantly to my self-development. Now moving to the next slide, introduction to microwave oven. A microwave oven is a kitchen appliance that heat and cook food by exposing it to electromagnetic radiation in the microwave frequency range. Our project involved the development of a microwave oven with 4 distinct modes: micro mode, grill mode, convection mode, and start mode. This mode enhances the versatility of the microwave oven, catering to variety of cooking needs. Whether you want to quickly heat up your food, get a nice grill on your chicken, bake using the convection mode, or simply start your regular cooking process. Moving to the next slide, functionality of these modes are in micro mode. This mode is used to cook food in a traditional way. It can use the maximum power of 900 watt and maximum time limit is 60 minutes. In grill mode, this mode is used to cook meat and bread. It works as the micro mode, but the purpose of this is to cook meat and bread. In convection mode, user can set the oven to preheat for a particular temperature and it takes 3 minutes to preheating the oven. After the preheat is done, then the user can set time as per the requirement. Moving to the next slide, the requirement for our project include the following component and software. MPLAB. This is an integrated development environment for the development of embedded application on microchips, PIC, and the PIC microcontroller. XC8 compiler. This is a compiler from microchip used for programming in C. It's specifically designed for microcontroller. PICSIMLab, Programmable Intelligent Computer Simulator Laboratory. This is a real-time emulator of development board with integrated MPLAB. In PICSIMLab, we will be using the PIC16F877A microcontroller. PIC16F877A microcontroller. This is a powerful 200 nanosecond instruction execution, yet easy to program, only 35 single word instruction. CMOS flash board, a CMOS flash based 8-bit microcontroller. 16:4 CLCD display. This character liquid crystal display will serve as the user interface for our microwave oven. Matrix keypad, MKP. This will be used for user input, allowing user to select different modes and enter cooking times. Tactile switches. This will provide a physical interface for user interaction. Timer. This is a crucial component in any microwave oven, ensuring accurate cooking times. By integrating this component, we aim to develop a functional and user-friendly microwave oven simulator. Moving to the next slide, microcontroller and microprocessor. These are two types of electronic devices that are widely used in embedded systems and other applications. A microcontroller is a single chip that contains all the components needed for a specific function such as CPU, memory, input-output port, timer, and other peripherals. A microcontroller is less flexible and less complex to design, but it is also cheaper, smaller, and more power efficient. Some examples of microcontroller are Arduino, PIC, and Aviar. On the other hand, microprocessor is a chip that contains only the CPU. It requires external components such as memory, input-output device, other peripheral to perform a function. A microprocessor is more flexible and more complex to design, but it is also more expensive, large, and less power efficient. Some examples of microprocessor are Intel, AMD, and ARM. We are using microcontroller for our project to build or to develop an microwave oven. Now, in our project, we have several components connected to the PIC16F877A microcontroller. Number 1, GPIO, General Purpose Input Output. These are versatile pins which can be configured as input or output for interfacing with other components. EEPROM. This is used for storing data that need to persist even with the microcontroller is power off. Sensor. This is used for taking input from the environment which can then be processed by the microcontroller. ADC, analog to digital converter. This is used for converting analog signal like those from sensors into digital data that the microcontroller can process. RS-232. This is a standard for serial communication that allows the microcontroller to communicate with other devices. LEDs, light emitting diode. These are used for providing visual feedback to the user. SSD. This is used for displaying numeric data to the user. Digital keypad and matrix keypad. These are used for taking user input. Buzzer. This is used for providing auditor feedback to the user. CLCD. Crystal liquid character liquid crystal display. This is used for displaying text data to the user. Each of these components play a crucial role in the functionality of our project, and they all work together under the control of the PIC16F877A microcontroller. Now, moving to the next slide, CLCD. CLCD stands for Character Liquid Crystal Display, which is a type of display that can show text and some special character. It is composed of a matrix of liquid crystal cell that can be turned on or off by applying electric voltage. In Pixim Lab, there are two types of CLCD available, 16:2 and 16:4. This number indicate the number of columns and row of characters that the display can show. For example, 16:2 display can show up to 32 characters in 2 lines, while 16:4 display can show up to 64 characters in 4 lines. To communicate with the CLCD, we need to use either 4-bit mode or 8-bit mode. This mode determines how many data bits are sent from the microcontroller to the display at a time. In 4-bit mode, we need to send 4 data bits twice to form 1 byte, while in 8-bit mode, we can send 1 byte at once.
The advantage of 8-bit mode is that it requires few pins from the microcontroller, while the advantage of 8-bit mode is it is faster and simpler. In our project, we'll use 16:4 CLCD display in 4-bit mode to show the status and setting of our microwave oven simulator. We'll use the CLCD library provided by PiximLab to initialize and control the display. Now moving to the next slide, a matrix keypad or MKP is a type of input device that allows user to enter data into a system. It consists of a grid of buttons arranged in a row and column. When a button is pressed, it connects a specific row and column which can be detected by the microcontroller. The advantage of using a matrix keypad is that it allows for a large number of input while saving on the number of input-output lines required from the microcontroller. This is because each row and column in the matrix corresponded to the I/O line. So the number of input is the product of the number of rows and columns rather than the sum. Matrix keypad are commonly used in devices such as telephone, calculator and digital locker where a large number of user input are required. In our project, we will use a matrix keypad to allow user to enter cooking time and select mode on our microwave oven simulator. We will use the MKP library provided by PiximLab to read the keypad input and process them in our program.
Next is interrupt. An interrupt is a communication process set up in a microprocessor or a microcontroller in which an internal or external device requests the microprocessor or microcontroller to stop the processing. Then the microprocessor or microcontroller acknowledges the request and attend to the request. Goes back the processing where it got interrupted.
ISR, Interrupt Service Routine, is a special kind of software routine that is automatically executed by the microcontroller in response to a specific interrupt. An interrupt is a signal that temporarily halts the main program and allows the microcontroller to execute a different task. When an interrupt occurs, the microcontroller completes the instruction it currently executing and then disable global interrupt. It then plays the address from the program counter on the stack. This process ensures that once the ISR has finished executing, the microcontroller can return to where it left off in the main program. The ISR attends to the request of the interrupting source by clearing the interrupt flag. It's important that the ISR saved any registry content that may be affected by the code in the ISR. This is to ensure that any ongoing operations are not disrupted. Finally, an ISR must be terminated with a RETIE instruction. This instruction enables global interrupt and return control to the main program. In our project, we will use the ISR to handle various events such as button press on our matrix keypad and time update from our timer. This allows our microwave oven simulator to respond promptly to user input and accurately keep track of cooking times. Next is timer. A timer is a peripheral device that can measure and generate time interval based on a system clock or an external clock. It has many applications in embedded systems such as measuring time and generating delays. A timer can operate in two modes, timer mode and counter mode. In timer mode, the timer counts the tick of the system clock or an external clock. In counter mode, the timer counts the event that occur on an external pin. The resolution of a timer is the number of bits that it can store. For example, an 8-bit timer can store value from 0 to 255, while a 16-bit timer can store value from 0 to 65,535. The resolution determines the maximum time interval that the timer can measure or generate. The tick is the smallest unit of time that the timer can count. It depends on the frequency of the system clock or the external clock. For example, if the system clock is 4 MHz, then one tick is 0.25 microsecond. The scaling is a factor that can apply to the tick to increase or decrease the time interval. It can be done by using a pre-scaler or a post-scaler. Pre-scaler divides the input clock frequency by a certain value before feeding it to the timer. A post-scaler multiples the output of the timer by a certain value before sending it to other peripheral. In our project, we will use a timer to keep track of the cooking time, display it on our CLCD. We will use the time library provided by PiximLab to configure and control the timer. We will also use an ISR to handle the overflow interrupt of the timer and update our program accordingly. Now, let's move on to the most exciting part of this presentation. That is the demonstration of our project, the microwave oven. I will take you through the various features and functionalities that we have implemented. So let's dive in. Now let's power on our microwave oven. As you can see on the CLCD, there are 4 modes available: a micro mode, grill mode, convection mode, and start mode. These modes are designed to cater to your various cooking needs. Whether you want to quickly heat up your food, get a nice grill on your chicken, bake using the convection mode, or simply start your regular cooking process. Let's start with the micro mode. As we select this mode, we can see on the CLCD that it shows 900 watt, which is the maximum power limit for this mode. Now, to set the cooking time, we use the metric keypad. The hash key is used to enter the time and star key is used to clear any input. Now, second is grill mode. The grill mode operates similarly to the micro mode, where we can set a time for cooking. Moving on to the convection mode, this mode requires you to enter the desired temperature for your cooking. One unique feature of this mode is that it required a preheating period of 3 minutes to reach the set temperature. This ensures your food is cooked evenly and thoroughly. Just like in the previous mode, you can use the matrix keypad to enter the temperature with the hash key for entering and star key for clearing any input. Lastly, we have the start mode. In this mode, the default timer is set to the 30 seconds. This mode provides you with option to resume, pause or stop the cooking process. This gives you full control over your cooking and allow for flexibility based on your needs. That's all. Thank you for your attention. I hope you enjoyed my presentation and learned something new. I have shared with you my learning journey during my internship, where I gained valuable knowledge and skills in the field of embedded system and microcontrollers. I have also demonstrated a project just now that I developed using the PIC16F877A microcontroller, which simulates the functionality of a microwave oven. This project showcased my ability to apply the concept and technique that I learned during my internship at Emerge, such as C programming, CLCD, MKP, ISR, and timer. I am grateful for this opportunity and I look forward to further enhancing my knowledge and skills in this domain. Thank you.